Hi, my name is Sawyer Hawgood.
And I'm Hayley Logan.
And today we will be presenting the West Virginia Institute of Technology Traffic Flow Project. So we have three main intersections that we're going to be taking a look at. The first one is South Kanawha and Church Street, and that's the top left-hand star. And then Church Street and Minnesota, which is directly below it. And our last one is South Kanawha and Mount Hancock, which is the right-hand star. So the current issue with Church Street and South Kanawha is that there is slight obstructions on the left and right-hand side of Church Street, which is the law office and the actual church. This is prohibiting safe left-hand and right-hand turns, and this is causing vehicles to pull out onto the crosswalk or South Kanawha Street itself, so pedestrians don't feel safe to use the crosswalk. So as you can see in this video, there's two pedestrians. They don't feel safe to use the crosswalk because this car is pulling in front of them, so they're actually going to go behind. And because of this, it is causing a traffic jam, and the cars are piling up, unfortunately, in this intersection. So this is the current design of the intersection. There isn't any stop signs or traffic lights. And this is just a different angle going northbound. So in our design process, there was a couple things that we had to look at. There is insufficient construction space on Church Street and on South Kanawha itself. There's buildings and sidewalks that you can't really cut into. So we referenced a previous traffic analysis which put traffic lights versus stop signs. So ultimately for our final design, we came up with a three-way stop using stop signs. So this would look like a stop sign being put here and also a stop sign being put here. The setback to this road is South Kanawha is a state road. So although we can propose this and we think that this is a good design, ultimately they have the final say so.
So for Church Street and Minnesota Avenue, the current issues are insufficient road width, site obstruction from the church, and the pole on the corner of Church Street in Minnesota obstructs vehicles turning. The effect of these issues causes vehicles to cross into oncoming traffic. Two vehicles are not able to use Minnesota at one time, and a right-hand turn onto Minnesota is affected by the pole. So as you can see from this angle, this is the pole. So coming from Church Street, turning onto Minnesota, this pole causes a tight turn, and two vehicles are not able to come. One cannot come up Minnesota while someone's turning down Minnesota. And you can also see how close the stop sign and sidewalk are. They're touching the church basically, so we cannot expand the road towards the church at all. And from this angle you can see this land. We could expand the road towards this side, but we do not own this property, so right now there's nothing we can do about it. So again, that with Church in Minnesota, there is insufficient construction space due to the church and the land that we do not own. And we referenced current traffic analysis that we took ourselves. And from this data, we decided to make Minnesota a one-way or do nothing. So if we made this a one-way, we would have a sign here going down Minnesota would be the one-way. So for our final design, a quick fix would be a one-way, but we think long-term we should wait for campus expansion before we do any major changes to this intersection.
So our current issues for South Kanawha and Mount Hancock, this is the intersection that we did the most design work on. So the cause is that it's insufficient road width and there are dangerous turning points. So this has caused car-on-car collisions. There's actually been 2 on campus thus far and major traffic jams within this intersection. So as you can see from this video, 2 cars cannot use Mount Hancock at the same time, and it's causing a traffic jam on South Kanawha. So that's what we're trying to avoid. We're trying to avoid traffic jams, and we also want 2 cars to be able to use the road at the same time. And then in this video, you're going to see a car coming out from Mount Hancock, and then you're also going to see a red car come on South Kanawha. You see how far back the red car is stopping because it's trying to give the car making a left-hand turn the right amount of space, and the car is going to make a right-hand turn down Mount Hancock, and you can see how close it actually gets to the car coming up from Mount Hancock.
So the original design of this intersection, the road width right now is 20 feet wide, and the sign location of our WV Tech sign is to the left-hand side of Mel Hancock. And as you can see, on both sides of Mel Hancock, the turning radius is basically a 90-degree angle. So the main cost issue we have with this intersection is an electrical pole, which is this yellow X right here. So for the first design, which would be roadway expansion, we plan to expand Mel Hancock. Instead of having it a 20-foot road, we'll make it 30 feet with a sidewalk coming to the right-hand side of 4 feet. And we change the turning radius on the right side to 30 degrees instead of basically a 90-degree angle. The sign location would remain the same. The one issue we have here is the pole, because coming down onto Mel Hancock off of South Kanawha is basically a 90-degree angle still. So we would have to move this pole, which is roughly $100,000. With this design, we would have to input a retaining wall as well.
So we used the base point on the close to the ground as possible, and we came up with 3 cross sections. So the first cross section is 17 feet. Each cross section would be buried 2 feet into the ground. We used a bioaxial geosynthetic grid, which was roughly 15 feet within, tethered into the retaining wall. So this is the 17-foot one. This is the 13-foot one, and then this is the 10-foot one. Again, all being buried 2 feet into the ground.
So our design 2 would be to input a merge lane into this intersection. The road width of Mel Hancock would stay at 20 feet, and the merge lane width would become 9 feet. So the radius of the merge lane is going to be 30 degrees. We would have to move the WVU Tech sign to the other side of Mel Hancock. One thing we did change, because we can't expand the road here, we changed the turning radius on the right side of Mel Hancock to 30 degrees as well. And we would also have to input a retaining wall with this design.
With this design, we wouldn't have to remove the pole because the merge lane avoids that. And the retaining wall, again, we used a base point and we had 3 cross sections. So the first cross section is roughly 14 feet with a 2 feet being buried underground. We made sure to put point loads on there and in all of our designs. So the heaviest thing that we could come up with was the food truck that comes once a week. And then we also put the surface load of the asphalt that will be a permanent load. So this is the 16 feet design. This will be the 13-foot wall. And the 6-foot wall, again, this will all be buried 2 feet into the ground.
So this is our third design for this intersection. This one is the combination of the merge lane and the road expansion. So again, the road will become from 20 feet to 30 feet with a 4-foot sidewalk. The merge lane and the road radius would be 30 degrees. We would have the same retaining walls on both sides that we showed before. And the only issue with this one is we're not sure where we would put our WVU Tech sign. And with this design, we would not have to move the pole. It's still questionable because of this turning radius, but because of the merge lane, it shouldn't become an issue.
So the pros and cons for each design, the roadway expansion, it increases the turning radius for 3/4 of the intersection. Like Hayley said, the turning radius going down onto Mel Hancock is still roughly a 90-degree turning radius, so that's what we're trying to avoid. In order to complete the optimal intersection, we would have to move that pole to make it a better turning radius, and this would come with an extra cost. So the pros for the second design, which is the merge lane design, this is the one that's going to reduce the congestion the most for the entire intersection, and it's also going to optimize the traffic flow out of all 3 designs. The cons for this one is you do have to move the WVU Tech sign. It interrupts pedestrian flow slightly because you're going to have to build a new crosswalk where the merge lane cuts into the sidewalk. and the Mel Hancock road width stays roughly the same.
So the combination pros is that this would fix all intersection problems. It would completely optimize traffic flow on campus. But the cons of the combination is the cost. It's the most expensive out of all three options because you're combining two projects into one. We also wouldn't know where to put our WVU tech sign, and it still interrupts pedestrian flow.
So our final design for this intersection would be the design number 2, which is the merge lane. In our final campus design, again for the first one, South Kanawha and Church Street, we would propose a 3-way stop using the stop signs, but this is ultimately the state's decision. Church Street and Minnesota Avenue, we would wait for campus expansion just to optimize that intersection as much as possible. And then for South Kanawha and Mel Hancock, we would do the merge lane.
Any questions? And this is all the softwares we use while doing this project and our references.
Thank you.
Thank you.